Hello and welcome. In this video, we're going to take another look at our P6 modified, and this is the practice version of it that will be similar to potentially your P6 as well as other projects. And so you might find these concepts useful then in other applications that you were working on. Specifically, this version of our P6 focuses on the inventory associated with a small kiosk or a small store, where we read in essentially the products.csv, we parse them into an array of structures. Now, the P6 modified version of this application focuses on the use of dynamic memory allocation. In other words, we're going to be using a combination of malloc and realloc in this particular function. And by this function, I mean we are going to be focusing on our copy products. Now, this is somewhat of a convenience function, if you would, meaning that it helps us simplify the code in our main. And if anything, it's technically not required, but you're going to see after this video is done with it, it makes it very useful in copying an array of structures to another array of structures. Now, to begin with, I want to point out a little bug that I have. And normally when I do this, I simply record one of the videos, possibly even re-record the content so that it makes it look seamless. But in this particular case, I thought it would be a valuable exercise for us to see a problem that came up between the recording of the P6 practice and this P6 modified practice. Now, I'm going to go a little bit further into the bug in another video, and I'll link the description to that video in the comments for this video. But what I want to do in this one is I want to go ahead and make the change in the function prototype as well as in the function stub so that we don't make the same mistake twice. And while it is a very minor bug, it does open the possibility for your application to crash. And as a good developer, anytime you see something like this, regardless of whether you're posting a video on YouTube about it, you should go ahead and try to fix it. So to begin with, let's talk about the problem. And again, I'm going to leave a more depth explanation of the bug in another video. But for right now, let's focus on this function signature. And you'll see that I'm passing an array of product properties, and I'm passing the address of the beginning of an array, or rather the address of a variable that holds the beginning of the array of product properties that is going to be our destination. And then the idea is that we're supposed to very carefully copy over essentially structure by structure from the sources to the destinations, assuming that we've maybe searched the sources for a subset then of the products that we're interested in. Now, the idea here is that our destinations may start off as a null pointer. In other words, basically an empty array. And that is where the problem comes in. We have to dynamically allocate the memory inside of the copy products function. Again, that's no big deal. We'll actually see that's fairly straightforward. We're going to allocate the memory structure by structure in this array. But you'll notice here that the N then translates to the sources. In other words, it tells us how many structures are in the sources array. And then the M tells us how many indexes we wish to copy. Now, where does the problem come in? Well, the problem is that if for some reason the indices point to an invalid element in the sources structure, well, we can abandon the entire copy if we want to. In other words, we could just simply change our exit success to exit failure. Or what we can do is we can simply adjust then the number of sources that have been copied to our destinations. And again, I'm going to dig in a little bit deeper in another video here, but fundamentally what that means is that we need to change the passing of the M from by value to by reference or by address. Now, there are a couple of ways that we can go about solving this problem. Again, I mentioned that we could simply just stop the copy if there was a problem, and that could be a valid solution. We could also add another argument to this function prototype and simply pass, I guess you could say, the M of the indices and then the M actual that was copied. However you want to go about doing it, that's fine. But for this video, to keep the function signature relatively similar to where we started, I'm simply going to make the change of the M from by value to by reference or by address. So let's go down now into the copy products and let's make that same change. Again, here we want to change our M to a address of M. And then what we will do is when we call the function, we will simply specify the address of the variable that is keeping track of the number of indices to copy. Now, at this point, then essentially the behavior of this function is very similar to the original copy products. The big difference, of course, is that in the original copy products, we were using statically declared memory. In other words, in main somewhere, we were just creating a gigantic array of structures with no real idea how many we were going to actually use until we loaded the file. In this approach, what we're going to do is we're going to allocate the structures as needed. Now, if you're not yet familiar or not comfortable with this concept, I encourage you to go back and look at the import products version of this project, and also go back and look at some of the pointers videos for the use of malloc and realloc. Now, we're going to be focusing solely on the use of realloc in this video. We're essentially going to take advantage of the fact that if realloc is passed a null pointer, that it simply then creates an address in memory from scratch, a new memory location. Again, you could argue that we're sort of cheating a little bit on this, but again, that is a feature of realloc. So let's go ahead and create some variables here that we will use. The first one that we need is actually going to be something called M validated, and we're going to make sure that it is a integer. In other words, it's going to keep track of the number of valid elements that were copied over. Now, whether we call it M validated or M valid, whatever makes sense to you. But the idea is then I'm going to use that to keep track of and then ultimately update the value of M that is passed. In other words, that way we know how many actual values are in our destinations array. And then the next thing, since we're dealing with realloc or dynamic memory allocation, we will also need a product properties pointer. And I'm simply going to keep the pattern that I followed, and I'm going to call this new, and in this case, new destinations. I try to prefix this with new, just to indicate that that is essentially the pointer address that is returned by realloc. Now, at this point, let's get into some simple validation of our input arguments. To begin with, the first one that we want to check is simply that our sources is not equal to null. And in this case, we just simply check to see if it is equal to null. If it is, we have a print statement that says, error, please provide valid sources. Followed by a new line. And then, of course, results are going to be equal to exit success, or exit failure, rather. I'm sorry. The default is exit success. All right, then we move on to our else if, and that is we probably want to go ahead and make sure that our indices themselves, for whatever reason, were not passed as a null value. And again, then we have a print F, error, please provide valid indices. And again, these scenarios are rather unlikely, but they are things that you need to check. And specifically, if you are intending to use dynamic memory allocation all through your application. All right, continuing on with that, technically, we would also need to make sure that the value of n is greater than or technically equal to 0. Didn't really make any sense for it to be equal to 0, but fortunately it does little harm in our application. But we definitely don't need the value of n, or for that matter, m, to be less than 0. So at the very least, what we want to do is let the developer or the user of our application know that something went wrong here. So if our n is less than 0, well, we again simply just provide some sort of message back to the user, arguably even a warning in this case, but we will let them know to please provide a non-negative n. Now, we're going to repeat this same process with our m, again, with one slight variation in the syntax, but either way, we're going to have then our results are going to be equal to exit failure. So again, what we can do is we can very carefully copy this block of code over, starting here and here. And then what we will do is we'll change our n now, and you'll notice that I have to use the dereferencing here of m to actually get the value of m. And so in this case, we just simply want to let the user know to please provide a non-negative m. Now, obviously, you can improve on these print statements. I would argue that these are borderline not helpful to the average user, but hopefully to the developer, it would make a little bit of sense here. But once you have validated then all of your input arguments to some level, then we can proceed to actually doing the copy process. Now, as I said, with this particular example, this one is going to be different because we are going to be allocating or growing the destinations array as we start copying values from the sources. And so as a result here, we're going to need a couple of values here to track. And one of them is going to be where we are in our sources array. And so in this case, what we can do is we can call this variable n index, or even just index if it is okay with you, if it makes sense to you. I like to use the n and the m just because we do have a scenario where we have two integer input arguments. Now, at this point, then what we want to do is we want to simply set up a for loop or a while loop. Does not really matter. Again, it depends on how you want your application to behave. In other words, if one of the individual copies fails, do you want the copy products to fail, or do you want it to survive to another iteration? And so what we can do is we can simply make it the copy products function fail whenever there is an individual copy product fail by simply using a compound condition in our while loop. And what we can do is we can check first to see if our results are equal to exit success. In other words, that's our condition to continue copying. And again, whatever order that we want to do this in doesn't really matter too much, except for in this case, when we want to check first to see if the previous iteration failed and then attempt to copy the next iteration. So in this case, then what we want to do is we want to check the two conditions while our results are equal to exit success, and that our n index is in fact less than our n. Now, at this point, you probably have noticed that I have not initialized some of my arguments, some of my local variables rather, and we definitely need to go about doing that. So let's take a second here to initialize my m valid, which will effectively be a counter or a track of the number of elements that I have copied. We also want to initialize our end index, and we need to do that because, as I said, we're using a while loop here. And then the third one that we want to remember to initialize, although it is not completely necessary in this case, is that we can go ahead and initialize our new destinations using a casting to a product's properties pointer and simply initialize it to null. Now, again, that's not completely essential in this particular example. If anything, it's just a good habit to get into to recognize how to cast pointers, excuse me. And then we want to do the same thing now, or decide how to handle our destinations themselves. Now, we had this discussion in an earlier video about what you expect to get passed. And again, there's a couple of different behaviors that you can work with, not the least of which is that you can actually be passed an address to a block of memory already. Now, this particular function assumes that you are not being passed a block of memory, or that you don't wish to reuse the block of memory that is being passed. And therefore, you probably want to consider checking to see what destinations is already pointing to, and possibly consider freeing up the memory. Again, I will cover that in another video where we focus in depth on how to clean up after yourself while you are doing dynamic memory allocation. But to begin with, what we want to do is we simply want to point, if you would, the destinations also to a null pointer. In this case, again, we're going to cast it to our product properties and essentially assign it the value of null. And again, I'm going to put a little note here that we need to consider this or even reconsider this then later on. And if I get a chance to, I may come back and modify this particular function. For now, we're going to make sure in our main that we're also setting the value of destinations equal to null. Again, depending on what type of application you're writing, that may not be the scenario that you wish to follow. At this point, then, inside of our while loop, we should be ready to simply copy the appropriate elements from the source to the destination. And what does that mean? Well, it means that we need to check that our indices at a given n index isn't accidentally pointing outside of bounds in our sources array. In other words, basically, if for some reason a negative value crept into our indices, then essentially you would be pointing to a negative element in our sources array, which would make absolutely no sense. The other scenario, of course, is that for some reason in the indices, you are pointing to a value that is larger than n. And essentially, remember that n in this particular version of our application represents dynamic memory allocation. And essentially, then it tells you how large your sources array is. Well, in this particular case, if you're pointing to a value that is greater than or equal to n, you're essentially pointing to a place in memory that is outside the allocated portion of memory. And again, that represents a problem. And depending on where you are ultimately trying to copy from, may end up resulting in a crash of your application. So what we need to do is we need to check those two conditions. And the first one is going to be the easier of the two. So we'll start with that and we'll figure out from there how we can proceed. But we will have a compound condition, and that is we will check to see if our indices square brackets index is in fact negative. And if it is negative, then we do not wish to proceed with the copy. So one way to write this, of course, is to check to see if it is greater than or equal to 0. And again, 0 is perfectly fine because that essentially means that it's the 0th element of our sources array, which in C, since C is zero-based indexing, that is an acceptable index inside of our sources array. Now, the second condition that we wish to check, and again, there's a couple of ways that we can write this, is going to be that our indices square brackets and index, is going to be less than our n, in other words, less than the size of the sources array. And if those two conditions are met, then what we're going to do is we're going to attempt to copy the structure. Now, under the else, then basically what happened is print f error invalid or attempted to copy an invalid index. And you can even go so far, if you wish to specify what that index is. And I'm just simply going to provide it with a %d for the placeholder. And then here we will simply use indices square brackets index. And again, that will tell you then what value of our sources array we attempted to copy. And in this case, it's going to be our n index. Now, again, this may in itself also lead to a bug, so you want to be really careful about how you go about doing this. But again, you have to trust something in your code. And at this point, we're going to assume that the individual values in our indices array are, in fact, at least valid integers. And again, what you could do is you could just simplify this, or at least remove the possibility of another bug by removing this %d. And then at this point, then you could decide whether or not you wish to stop the copy process. If I decide to stop the copy process here, well, I would simply say results are going to be equal to exit failure. Now, again, that is one possibility. However, though, this is the point of this particular copy products, is to be a little bit more robust. In other words, we do not necessarily want to exit at this point if we simply have an erroneous index being passed. In this case, basically what we're going to do is we're going to continue, except we're going to continue with the next element in our array. And so in either scenario, whether we go down the true branch of the if statement or the else branch of our if statement, we simply want to increment our index. Again here, n_index. Now, let's focus on what it means to actually attempt to copy the structure. And since we are dealing with dynamic memory allocation, that means that we have to allocate the memory up front and then copy. So the first step is going to be to alloc the memory, or realloc in this particular case. And if you recall, part of that process is we want to check to see if the memory was allocated. So that is the reason then for our new destinations pointer, and that we simply then once again are going to cast the results to a product properties pointer of our realloc. We want to pass to it the original destinations, even though we've set it to null, because again, as I mentioned in the initial portion of this video, if its realloc is passed a null, then it's essentially going to behave like malloc. And we want to specify now the size, which is where our mValid index or mValid variable comes into play. And so we're going to go and use some parentheses here. We're going to say mValid +1 because we essentially want to grow the size of the used portion of memory. And we simply multiply it then times the size of, in this case, our product properties array. Now, at this point, we need to check to see if our new destinations is equal to null. And if it's equal to null, now we do actually have a problem on our hands. In other words, we want to say error, failed to allocate memory. And at this point, there's probably no reason to proceed with our copy. In other words, there's probably something more important going on or bigger going on in your application, or perhaps in the amount of memory that you have available on your computer, or perhaps you've simply allocated memory in an infinite while loop. So again, you want to be really careful about this. And so at this point, then what we're going to do is we're going to now set our results equal to exit failure. Now under the else branch is where we want to proceed now with essentially shifting the value from new destinations to destinations, and now pass a valid location in memory to our individual copy function. So at this point, our next step is going to be to simply take our destinations variable. Remember that this represents then the address of the start of our destinations array. And we simply want to assign to it the value that was returned by realloc and temporarily stored in our new destinations variable that represents the address of the larger block of memory. Now, keep in mind, this does not mean that it's a single structure. This is actually going to be an array of structures. And so as this while loop runs, you're going to simply keep increasing the size of the block of memory that is allocated for your array. Now, it is worth pointing out in this particular example here that we are growing the array one structure at a time. You could argue that this is inefficient, and I would probably agree with you, except for the fact that our particular structure is fairly large. If we were doing this with a single character, then that probably wouldn't make a whole lot of sense. But as we saw in an earlier video, this particular structure is over 100 bytes in size. And again, if you know something about your file, then perhaps you still want to allocate this in blocks of 10 or even blocks of 100. For right now, we're going to accept the trade-off of running the realloc multiple times or one time for each copy, and just accept the fact that this is a place for optimization. Now, at this point, we want to be careful about which block of memory in our destinations array we are wishing to use as the target for our copy function. And in this case, what we'll do is we're going to be very careful. We are going to use our copy product singular. And for the source, well, the source is going to be pretty straightforward. It's just going to be the sources, square brackets, and then we're going to use, again, our indices array to specify which value in our sources array that we wish to copy. So we're going to actually be using nested square brackets here. And for the second nesting will be the n index. In other words, the current index that we need to copy in the sources array. And then ultimately, we've got to figure out then how to copy it to the correct location in our destinations. And again, from an earlier video, you saw the necessity of putting the parentheses around the destinations variable when it is being passed, or rather when it is an address in memory. So basically what we want to do is we want to specify that address in memory, and then we want to specify a specific element of that array, because remember that the destinations points to the start of an array of structures, and we simply need to know where in that array of structures we wish to copy the source. And in this case, that is, again, where our mValid comes into play. Now, in the earlier version of this video, I actually used the m, which was driving then our index, and that was the source of the bug. And again, we'll come back to that in a later video about why that would have blown up on us. But in this particular case, we have fixed this by simply providing then our mValid. In other words, basically what this does is through a combination of the realloc, where we've allocated a new location in memory, and the use of mValid, then we simply are incrementing forward in our destinations array each time we find a valid source to copy from. And at this point, then the only thing left to do is to simply update our mValid. And then the goal here is that we wish to then pass back to our calling function the updated m. If we do not do so, then it will have no idea of how big our destinations actually is. And again, like I mentioned at the beginning of the video, you can either pass this value by reference or by address. You could add, for instance, another argument to our function signature. For that matter, you could actually change this from exit success to exit failure and leverage the int for the return value, or you could simply just stop the copy process altogether whenever an invalid source is reached. And again, that would be when we have this scenario right here, in other words, where these two criteria fail, that we simply then stop our while loop. Now, as such, then the last thing that you want to do after you fall out of your while loop for either results equal to exit success no longer being true, or that you've ran out of things to look for in your search algorithm. By the way, I just realized that we do in fact have one other problem here. I did make a mistake, and I'm glad we caught it here. We actually needed to have this be our m index. My apologies here. I've actually got my while loop wrong. So it is actually going to be m index less than m. And so please take a note here that second condition was in fact wrong. And then we need to go through and simply change then all of our references to our n index. Let's make sure that we don't have any more mistakes here. So everywhere we had our n index should in fact be m index. Everything I said in the early portion of the video was correct. The only thing is I actually am using the wrong variable name here. So please take a second to change this from n index to m index. And I think we caught all of them. All right, so then the outside here of our if statement, we simply want to then increment our m index plus 1. And the idea is then that we would loop through all of our indices until we ran out of indices to search. And then outside of our while loop, we simply assign back to the original m the value that we have updated for our m valid. And again, what this does is this tells the calling function the actual size of the copied and validated destinations. Without that, you will accidentally go past the end of the destinations array in the event that there was an invalid source. So as always, hopefully you found this video useful. We will test this function in later videos. If you have any questions, comments, or concerns, don't hesitate to reach out to me, and thank you for watching.